Lesson 19 is going to be on quadratic functions and inverse functions. Uh, but before we get to quadratic functions and inverse functions, I have a page here on some linear functions questions, which are questions really that we have already learned how to solve. You already know how to do this. I'm just including them here because sometimes these these type of questions that we have already learned how to do can be phrased a little bit differently, and I would like you to know, to understand, if the question is phrased this way, then you can still solve it even though it looks different to something we looks like something we have never done, but we have actually already done stuff like that. And it says the following. First of all, a quick definition. A function f is said to be linear if it is of the form f of x equals mx plus b, where m and b are constants. So this form mx plus b, it should remind you of y equals mx plus b, which is the equation of a line. So we when we discuss lines, we said that every line can be represented with an equation that we can always write in the form y equals mx plus b. So basically, this is just saying that if you have a function whose formula can be written in the form of x plus b, then that function is said to be linear. And it makes sense to call it linear because that would mean just that the graph is the graph of that is just a line. What line? The line y equals mx plus b, because y equals f of x. So it's really something that we have already learned, but just not put in the context of functions instead of just lines and equations, but actual functions, rules of assignment. All right, so look at this example. Again, you already know how to do this. Just phrase it differently. He says a linear function satisfies f of negative 1 equals 4 and f of 3 equals 7. Find f of x. Okay, so saying that the linear function satisfies f of negative 1 equals 4, remember that this is just the x, and then when you plug in, this is the input, which is x, and then when you plug it in and you get 4, that 4 is supposed to be the output, which is y. So that means that if you rephrase this slightly differently, that means the points x, which is negative 1, comma 4, y, 4 for the y, that point is a point on the line on the graph, and the corresponding point that you get from this, which is 3, 7, the points negative 1, 4, and 3, 7 are points on the graph. And the graph is a line. And what we're going to do is we're going to find the equation of this line, which is a line. Okay, so we're going to find the equation of this line as always, as we already learned how to do it. So we're going to use the formula for finding the equation of a line. And first of all, we need the slope. So the slope, find the slope of the line that passes through these 2 points. So subtract the y's. So this is y2 minus y1 over x2 minus x1. And this is 7 minus, subtracting the y's, minus 4 over 3 minus negative 1, which is 3 over 4, because negative and a minus and negative 1 becomes a plus 1, so the bottom becomes plus 3 plus 1, which is 4. All right, so that's the m. And now we can use either of the 2 points for our x1, y1. And remember that I usually prefer to use the points that don't have any negatives because it makes it easier. When you have, it's good to avoid negatives if you can, because negatives are a big source of common mistakes. So I'm going to use this one instead of that one because I want to avoid negatives. So this is going to be my point, okay? I'm going to use that one when I plug it in the formula. The formula being y minus y1 equals mx minus x1. So plugging in that in that, I'm going to get y minus y1 is 7, equals m, which is 3/4, x minus x1, which is x minus 3 because I'm using that point. Again, you don't have to use this point. You could have used this one. It doesn't really matter what x1 and y1 stand for. It could be any point. Okay, so then that's the equation, and now we're just going to put in the usual form, which is y equals mx plus b, and then that formula, the mx plus b part is what f of x is. So let's do that. So this is going to be distribute here and move the 7. So this is going to be y equals 3x, 3/4 x, multiplying here you get negative 9/4, and then I'm moving also, I'm doing all of that at the same time because I'm running out of space. So I'm going to move the 7, you're going to get plus 7. And simplifying, this is 3/4 x, and now you can put that in the calculator, just do it by hand. Negative 9/4 plus 7 is negative 9 over 4 plus. This is over 1 times 4 times 4 is 28/4, which is 19 over 4. 28 minus 9 is 19. So positive, so plus 19 over 4. And this part right here is your f of x. So that means the answer is f of x equals 3/4 x plus 19/4. That is the formula for f of x. So instead of basically, again, instead of writing y equals mx plus b, we write an f of x equals mx plus b, y equals f of x. So that's all. That's the only difference. But it looks, if you look at it, it's worded very differently, and we just basically had to like kind of like translate it to something we are familiar with. So this means there's 2 points that are on the graph. In the graph is a line. And how do I know it's a line? Well, they're telling me I'm looking for a function whose graph is a line. It says a linear function. Okay, let's do another one. Same thing, different numbers. So suppose I have a function that is linear. I'm looking for a linear function that satisfies f of -1 equals 4 and f of 8 equals 9. Find f of x. Okay, translating this again, this means that the points -1, oops, -1, comma 4, and 8 for the x and 9 for the y are on the graph of f. Again, which is a line because they're telling me it's a line. If they didn't tell me that, I wouldn't know. It says right there, which is a line. Okay, so what we're gonna do is find the equation of this line. And if you have 2 points, the way you find the equation of that line is, first thing, find the slope. So slope is subtract the y's, any order, just be consistent. So I like doing it like that, left to right, right to left. 9 minus 4 over 8 minus -1, which gives me 5 over 9. So that is the slope. And now you can use either of the 2 points to be your x1 and your y1. And I'm going to use the one that is both positive because, again, I like avoiding negatives. So I'm going to use this one. So 8 and 9. All right, so then let's plug in. So you're going to get y minus y1 equals mx minus x1. That's a formula that you're supposed to know. Plugging in my numbers in there, we're going to get y minus 9, y1 is 9, x1 is 8, equals 5 over 9 x minus 8. Okay, so maybe in this case it would have been better to use that one, because even though you have negatives, the numbers are slightly smaller. But okay, whatever. You have a calculator, so this is not a big deal. So this is going to be y equals, then distribute. So this is 5 over 9x minus 40 over 9. And then I'm moving the plus 9 to the other side. Okay, and then we're going to simplify this. You can, again, put that in a calculator or do it by hand. Negative 40 over 9 plus 9. You can think of it as over 1 and then times 9 times 9. This is going to be negative 40 plus 81. And 81 minus 40 is just 41. So 41 ninths. So this is 5 over 9x plus 41 ninths. And this part right here is your formula for f of x. So the formula for the function f of x equals 5 over 9x plus 41 over 9. All right, and that's all. Now let's talk about quadratic functions, which is section 7.5 in the book. So a quadratic function is something that we have already encountered, is a function that is of the form f of x equals ax squared plus bx plus c. We have encountered this type of expression when we're solving quadratic equations, right? That we solved using the quadratic formula. So this is also not an entirely new concept, but now we're looking at it from a new perspective, which is the functional perspective. We're thinking of it as looking at it from the point of view of functions instead of just solving equations. Okay, so you have the function looks like this: ax squared plus bx plus c. This, when you have it like that, in that form, that is called the general form of the quadratic function. There's in general two forms in which you can offer a quadratic function. This is the so-called general form. Now, there's another useful way of expressing this, rewriting this, by using the method of completing the square. If you completed the square here, you can actually rewrite this function in a different form, and it would look like this. You can write it this way. When you write it in such a way, so it's basically the form a, and then you have x minus something squared. This a is the same as that a, and then you have this h, and you have this k, and this k and h are not the same numbers as the b and c. They're different numbers that you get from the process of completing the square. But I'll tell you how to find them in a minute. So you get this h and this k, but the function looks like the a, which is the same a as that one. The h and the k are different, but the a is the same. A times x minus h x minus something squared plus k. So that one is called the standard form of the quadratic function. Okay, the standard form of a quadratic function. The graph of a quadratic equation or a quadratic function is called a parabola. The graph of a quadratic equation or function is called a parabola. Okay, so we're going to be talking then how to draw parabolas and how to describe some of the basic shaping properties. So parabolas are functions, they're going to look like this. We already discussed them very briefly when we were talking about the toolkit functions, and I told you, these are the basic functions for which you have to have an idea of what the graph looks like. And for for functions of degree 2, like the x squared, the basic function is the x squared. The basic graph of that looks like this. I mean, so is this one right here for x squared. But in general, for a quadratic function like this, it's gonna either look like this or like that. All right. So of these two ways of writing the equation, the very best one or most useful one is this form, the standard form. And that's because it gives you a better idea of what the graph looks like. It gives you more information. Just by looking at it, you know more stuff about the graph than by just looking at the function like this. All right, so what information do you know by just looking at it if it is in the standard form? You know immediately by just looking at it where the vertex of the parabola is. The vertex is this point right here is either the lowest point if it is a parabola that is opening up like that, or the vertex would be right here, this point, which is the highest point if it is a parabola that opens down. So it could be the lowest point or the highest point. It's a vertex. Uh, so by just looking at it, you know what are the coordinates of that vertex. The coordinates of that vertex are h and k. So if you write it like that, so for example, if you had like 5x minus 1 squared plus 7, then I know right away, without doing anything, basically for free, that 1, 7 are the coordinates of the vertex of that parabola. Okay, and so that's if you have it in standard form. What if you don't have it in standard form? What if you have it? What about if you have it in general form? Well, in that case, there's a neat little formula that normally you memorize this. It is, the formulas are like this. The h is going to be negative b over 2a. And the k is just going to be what you get when you plug in h in the formula for f. Okay, so basically the k is just what you're going to plug in this h. So the one that you really have to memorize is this one, because then the k is just plug it in. Plug it in the f. Okay, this right here, so where does that come from? That comes from completing the square, as I said right here. If you complete the square, here you're going to get h, and it turns out that the h is given by this. Because remember, the completing the square, I don't even remember the procedure, but you divide by 2, and then you square, and then the term that goes in there is just what you get when you divide by 2. So anyway, and you can also get it from using calculus. So that's where the h comes from, and that's what it is. Normally, again, you just memorize it. Negative b over 2a, that gives you the h, and the k is just what you get when you plug in the h. All right, so there you have it. Now we know how to find the vertex in either scenario. If it is like this, just read it off. HK is a vertex. And if you have it like this, then the H is negative B over 2A, and the K is what you get when you plug it in. And note that the H is the opposite of what you see here. If I see a minus, then it's going to be positive H. If I see a plus, it's going to be negative H right here. So if you see like a plus, if this was like a plus 5, this would be negative 5. If this is a minus 5, this would be positive 5. And so on. It's the opposite. All right, and one more thing about the graph is that if the A is positive, the graph is going to open up like that. And if the A is negative, the graph is going to open down like that. And also, the parabolas are symmetric with respect to the line that passes right through the middle. The coordinates of the vertex are HK, and the line that passes right through the middle is always the line x equals h. That is the equation of the line that passes through the middle. That's called the axis of symmetry. The axis of symmetry is the same for both, whether it opens up or down, doesn't matter. So x equals h is the so-called axis of symmetry. The parabola is then symmetric with respect to this axis of symmetry, which is the equation, which is the vertical line x equals h. Now, one last thing before we do some examples. The vertex is sometimes called the turning point by some people. Oops. The turning point of the parabola. So the vertex is sometimes called the turning point of the parabola. And again, if it opens up, it is the lowest point. If it opens down, it is the highest point. And also, one more thing, and this is kind of pretty important in calculus, the way you call things in calculus. In calculus, the k value of that vertex, the y coordinate, which is the k, is called the maximum if it opens down, or the minimum if it opens, the maximum if it opens down like that, or the minimum if it opens up, depending on which situation you have, the maximum or the minimum value of f. So another way they could ask you find the vertex of the parabola. In that case, they're basically telling you find h and k, or they could tell you find the maximum value of the function or the minimum value of the function. In that case, they're asking you just for the y coordinate of that vertex. Of course, you do it exactly the same way, but in that case, you just report to the k. You don't report the h unless they ask you also when it happens. So you in that case, you would say the maximum value is blah, and it happens when x equals blah. All right, and that's it. That's all. Let's get to some examples. All right, so here's the first example. Find the vertex of the following parabolas. And also say whether the parabola opens upward or downward. Okay, so this is the easy case where the function is already in standard form. So there's two ways you could have it. If it is like this, you can immediately tell what is a vertex. If it is not like this, I mean, if it is not like that, but like this, then you have to work a little bit more and use these formulas. So we're going to start with that example, which is the easy one. So basically, you just compare, right? So the function in standard form is supposed to be a times x minus h squared plus k. And just comparing directly, you can tell what a and what is h and what is k. So just comparing, you can tell that a equals -2, direct comparison. You can tell that the h equals 1 because you have the x, you already have the minus, and what is after the minus is an h, and in here, what is after the minus is a 1. So that means the h and the 1 have to be the same. And lastly, the k equals 5. So just by direct comparison, you can get to the what is everything, the a, the h, and the k. And the vertex is the hk, which in this case is just 1, 5. And the fact that a equals -2, which is negative, it opens down. When a is negative, it opens down. So it opens downward. So that answers the question, both parts. What is the vertex? The vertex is 1, 5. And does it open upward or downward? Well, a is negative, so it opens downward. All right, now doing the same thing for the next one. Again, this is just a direct comparison because it is already in standard form. Directly comparing things, you get that the a must be 3. Here you have a minus in the original formula, but you have a plus in here. So these are opposites, so that means the h is also opposite, so that means the h is going to be -5. Because you're supposed to have a plus there, and you don't. You're supposed to have a minus in there, you don't. You have the opposite of that. You have a plus. So that means you have a +5. So that means the h is actually -5. And indeed, if you were to plug in here h equals -5, you have minus -5, which minus -5 is the same as +5, so, which is this. All right, and then k equals this part, -3. K equals the whole thing outside of that square. All right, of that parentheses. So -3. So then, now let's answer the questions. The vertex is hk, which is -5, -3. And A is 3, which is positive, and that means the parabola opens up like a cup. So positive opens up, negative opens down. Positive up, negative down, so that makes sense. All right, now let's answer the same question, finding the vertex, but starting with a function that is in general form. And then once we have the vertex, let's put it in standard form. Let's put it just looking like that, like the previous two examples. Okay, so let's find the vertex. The vertex is hk, where the h, if it is not in standard form, the h is -b, this is the formula, over 2a. -b over 2a, where the a and b are the same as in the quadratic formula. So the b is -4, so you have and the b is negative 4, over 2 times a, and the a is 2. So you get positive 4, because negative and negative is positive, over 4, which is 1. So the h is 1. And if the h is 1, what is the k? The k is just what you get when you plug in the h. So in other words, what you get when you plug in 1 in f. So now we're going to plug in 1 in here. In that, what you can do in calculator in your head. So let's do it in our head. So this is 1. So 2 times 1 squared, that's 2. Minus 4 times 1, which is 4. So 2 minus 4, that's negative 2. Negative 2 plus 5 is positive 3. So you get then that h is 3. So that means the vertex is hk, which is 1, 3. And using that, we can now rewrite the function that was originally in general form. We can rewrite it now in standard form, and it doesn't take any effort. This does not take any effort because the standard form is a x minus h squared plus k. But we already found the h and the k, and the a is the same as that one, the same a that we just used. So that means f of x equals, the a was 2, so 2 x minus 1, because h is 1, squared plus k, which is 3. Okay, so we found the vertex and put the function in standard form. Okay, we're going to do another example like this. So now let's consider this quadratic function. We're going to find the parabola, the vertex of the parabola, and then write the standard form. Okay, so the vertex is hk, where h equals, here's the formula, negative b over 2a, which is negative, the b is 12 over 2 times 3. The a is 3. So this is negative 12 over 6, which is negative 2. So we found the h. Once you have the h, the k is just what you get when you plug in the h. So k equals f of h, but we said that h is negative 2, so f of negative 2, and now we just have to plug in negative 2 in there. So 3 times negative 2 squared plus 12, negative 2 plus 1. This is 3 times 4, which is 12. This is negative 24 plus 1. 12 minus 24 is negative 24. Negative 24, sorry. 12 minus 24 is negative 12, and negative 12 plus 1 is negative 11. So that means the vertex is hk, which is negative 2, comma, negative 11. So that's the vertex. And lastly, to write down the function in standard form, here's the formula. I'm not going to write it again because it's right there in front of us. So, but we have the a, the h, and the k. We found them here. We have the h and the k, and the a is still the same. The a is 3, which is Put it in front of the x squared, that's the a. So then we can immediately write down the, the function, rewrite it in standard form. This is going to be a, which is 3, x minus h, which h is negative 2, so x minus h is negative 2, so x minus negative 2, squared plus negative k. And now you simplify this a little bit. You can say this is 3. Negative and negative gives you positive, so plus 2 squared. And then you can just leave this as plus negative 11, or if you prefer, you can write that as minus 11. Both are correct. So that's the answer. All right. Now I'm going to do one example where I do it using the method of completing the square. If you are happy with the way we did it in examples 4 and 5, then you can stick with that. There's no need then to um, learn how to do it both ways if you're happy with one. But one just means that you normally have to know this formula, okay? In this formula, however, if you remember what I said, formula comes from completing the square. So instead of memorizing the formula, you can just apply the completing the square method and get the same answer. So I'm just going to do one example where I do it without using the formula and just using the method of completing the square. But again, you can just do it any way you want. If you like this one that I'm going to about to explain, then you can use it instead of the formulas. All right, but all right, so I'm just doing one example like this. So I'm going to find, it's the same question, find the vertex, and then write in standard form. And I'm going to do it using the completing the square method, not not using the formula. All right, so the first thing, if you're going to use this method, is you're going to pull out. So I'm going to copy it first, but you're going to pull out the a, because the a has to be in front of everything of that, no matter what. So you have to factor it out. You see, it's factored out. You have to pull out the a. So I'm going to pull out the 2 from the first 2. So this is going to be, if you factor out the 2 from the first 2 only, so ignore the third one, whatever that is. From the first 2, you get x squared minus 4x. Just from the first 2. All right, and now we're going to complete the square. Okay, so I just copied everything, and now we're going to be adding the part that I need to complete the square. So the method of completing the square, if you remember, divide that by 2 and square that. So negative 4 divided by 2 is negative 2, squared is positive 4. So what goes in here is a positive 4. So positive 4, however, because that 4 is affected by 8, in reality, I'm not just adding a 4 that was not there, I'm adding an 8 because that 2 actually doubles my 4. So that makes it an 8. So that means I'm not really just adding 4, I'm adding actually 8. But I don't want to add anything that was not there to begin with, so I need to balance this out. So the 8 that I'm adding, I need to take it away. So that 8 that I just added, I mean, it looks like I added a 4, but again, I just added an 8. That 8 that I just added, I need to take it away so that I don't alter the balance. I don't alter things. I don't change the original thing given to me. All right, and now we just simplify. This is 2. Simplifying, this is the square of what? Well, this is just the square of x minus 2 squared is the coefficient divided by 2 squared. And then simplifying that, that is minus 6. Positive 2 and negative 8 is negative 6. And that's it, we're done. Note that this method gives you both, gives you the formula in standard form, and then from it you get the vertex. If you use the formulas, you get it backwards. It's kind of like you get the vertex and then you put it in the standard form formula to get the standard form. Here you get the standard form first, and from there you read off the vertex. So the vertex is, reading it off from there, is 2, -6. Remember the H is is the opposite of what you see there. So I see a -2, so it's a +2. All right, and that's it. If you like this method, you can use this method. If you don't like it, then use the formulas, as in examples 4 and 5. Okay, the last thing we're going to do is how to sketch a parabola. Okay, sketching a parabola is really easy, almost just as easy as sketching a line. For a line, you need 2 points. Any 2 points, you plot 2 points and you connect them, and there you go. You have your line. In the case of a parabola, you also need you're gonna need 3 points, but really you only work in finding 2 because the third one is for free. It's using symmetry. So here's the best way to quickly sketch a parabola. So how we're gonna do it. We're gonna determine where the parabola opens up or down and find the vertex. Just so you can visualize it, is it open up or down? That's the A. If the A is positive, it opens up. If the A is negative, it opens down. So you can start visualizing it even before you put pencil to paper to draw it. So and find the vertex. The vertex is the HK. We already know how to do it. How to do that. So you may use any method. It doesn't matter. So find the vertex. Then you basically need one other point that is not the vertex, and my recommendation is that you find the y-intercept. That's my recommendation. You don't have to find the y-intercept. You could use any point that is not the vertex, but I recommend the y-intercept. Okay? But let me put that explicitly here, or any point. It could be any point different from the vertex. And then you're going to use symmetry to find the third one, and you're gonna connect to them with a curvy shape, just like parabolas should look like, and you're done. So here's how this works. Um, so we're gonna graph the parabola from example 6, which is this one right here. So I'm gonna use this version, the standard form. It's kind of nicer. So let me copy it here for my convenience. So 2x minus 2 squared minus 6. Okay. So you find the vertex. Again, you don't have to put it like this. You could have used the formulas. Well, the vertex we had said is 2, -6. And note that my A is 2, which is positive, so that means my parabola opens up. And now you need one other point other than the vertex, and I recommend the y-intercept. Why? Because it's really easy to find. Remember that to find the y-intercept, all you have to do is plug in x equals 0. To find y-intercept, you plug in x equals 0. So let's plug in x equals 0 in here. So you're going to get f of x equals 2, and then 0 minus 2, which is -2, squared minus 6. This is 2 times 4 minus 6. 2 times 4, that's 8, minus 6 is -2. So that means the point is 0 for the x and -2 for the y. Okay, and now we're ready. That's basically it. We're ready. Let's sketch this. So the vertex is 2, -6. 2, 1, 2, 3, 4, 5, 6. Right there. This is 2, -2, -4, -6. This is 4, this is 6, this is 8. -2, -4, 2, 4. Okay. So 2, -6, that's the vertex. Keep in mind that it opens up. Now plug in any point, any other point, which I chose the y-intercept, so that's 0, -2. 0, -2 is right here. And then I need one more point, but the other point is for free by using the axis of symmetry. So we know that this is a vertex and that it opens up. And the vertex passes right through the middle. So I'm just going to draw this with pencil. The vertex, the axis of symmetry passes right through the vertex. Okay, so that would be like vertex. And then, because this is symmetric with respect to that, I just need another point that is on the opposite side of that mirror, of that axis of symmetry. And the distance between the axis of symmetry and this point that I chose is 2. So I just need to draw another point that is at the same distance but on the opposite side. So 2, so 2 to the right of the axis of symmetry, which is this. And there you have it, 3 points. Now you can connect these using a curvy. Okay, and that's it. That's my parabola. That's good enough. If you wanted it to be like really, really accurate, you plug in more points, but for a sketch, that's good enough. Okay, that's it.